This is my senior capstone project, which is integrating a pressure sensor onto a free ball and Niskin bottle. This is an overview of my presentation, the relevancy of the project, background information of the Niskin Bottle, pressure sensor, PlatformIO, ESP, various sensors that I used with Arduino on PlatformIO, and final code for the sensor, and the website and Bluetooth, and the Cad Model, the sensor integrated on the Niskin Bottle, conclusion, Q&A. The importance of the project. Projects help us become better learners and better engineers, and the skills we learn by doing projects make us better prepared for the real world. This project is important because it is a different kind of Niskin bottle that you would normally see, which is a free ball and Niskin bottle, which was designed and manufactured by my classmate, Andrew Smith, with a time release which automatically triggers the water sampling and releases weight. So integrating a pressure sensor onto this Niskin bottle will help make it take a more accurate water sample at a more accurate target depth pressure rather than a time release, due to the current underwater could make a release before you get to your desired depth. Background information. First is the Niskin bottle. They're relatively simple devices that are used to collect water samples within the water column at various depths. You can collect samples used for studying planktons, salinity, dissolved oxygen, nutrient concentration, dissolved organic and inorganic carbon. And this bottle right here, you can see it is attached to some sort of tether. And usually when you deploy it, the two stoppers on both ends are open. Once it reaches your target depth, this weight right here will hit the release mechanism and will cause the stoppers to close quickly and hold that water sample from that depth. Pressure sensor is just a device used for measuring the pressure of gases or liquids. It acts as a transducer, which generates a signal as a function of the pressure imposed. Can be used directly to measure other variables like altitude, depth, water level, speed, fluid, gas flow. And this is the programming platform that I used for all my programming purposes, which is PlatformIO. It's a cross-platform professional IDE. It's integrated development environment tool for embedded development. And this platform has way more features than the Arduino IDE, which makes it easier to create and troubleshoot the code. It means that way more libraries, way easier to use. It's a lot easier. I really like this program, but you use it through Microsoft Visual Studio's code. You have to add PlatformIO as an extension. And this ESP, what I use for the majority of my project, which is the expressive ESP32. And it's a microcontroller unit that has built-in Wi-Fi capabilities and Bluetooth for a wide range of applications. And I use this microcontroller for a lot of tutorials, like the Blink program, Hello World, and other tutorials that you can find on the internet. the various sensors I used. First one was the DHT22, which is a simple digital temperature and humidity sensor. It uses a capacitive humidity sensor and a thermistor to measure the air around it, and it spits out a digital signal on the data input pin. And you can see it only has 3 pins, one for the ground, one for power, one for the data input. And it's just a real simple code of getting the DHT22 to work. You see, you just include Arduino and the DHT library. You set the sensor, the pin number, flow temperature, humidity, and you set up your baud rate, begin the sensor, and the print sensor begin, and then the loop. And then the loop, you have the humidity and temperature where the sensor will read the humidity and the temperature, and it'll print out the temperature and humidity. And you see down here, it prints it out on the serial monitor. And then the next thing I did was a temperature threshold. So I set a temperature threshold up here. And the only thing that changed was right here, it'll say if the temperature is greater than or equal to the threshold, then it'll turn the LED on the ESP, make it blink when it's higher than the temperature threshold. So say if it's higher, it'll blink. If it's not, it'll say it's below, and it won't blink. And you can see right here in the serial monitor, so sensor begin, reads the temperature, humidity. Since I set the threshold higher to 21, it's taking readings at 22, so it's going to print temperatures higher than the threshold. It'll make the LED blink. And there's the pressure sensor I used for the project. It's a BlueRobotic Bar30 to measure up to 30 bar or 300 meters in depth. It is waterproof, ready for installation, which makes it ideal to use on any sort of instrumentations such as ROVs, AVs, remote sensors, and it also includes a temperature sensor. I also figured out the response time with the help from Geo by using timestamp and the delta T. Right here, found out that the response time is 42 milliseconds. And I used the pressure threshold and the code to trigger the water sampling on the Niskin bottle rather than a time release. And there's the final codes. So I need to go through it, or I could say what I changed from last time to be hard to see. I think this too. So from the last time, my web server wasn't working, so I didn't have it set up properly. And right here is where I set up the web server. Set up the SSID, which says ESP pressure sensor, and the passwords ABC123. And this code's pretty long. It's like 6 pages. So some more stuff happening. This is the whole loop set up all right here. So there's a lot going on. Pretty tough. And once you build it, upload it, it'll put in the serial monitor. says I set the pressure threshold lower than the actual pressure. So say the pressure is higher than threshold, which will release the solenoid pin. It'll print it right here. It says solenoid retracted, and then turn everything off through the power pin. And then the Niskin Bottle will start making its way back up. The website Bluetooth. It's the web server that I created for the pressure sensor in order to get all your log information. And it's the URL, the link to the web server, but you have to be connected to the ESP Wi-Fi, which is ESP FC991, and it allows you to see the sensor logs, which contains all the measurements of pressure, depth, temperature, and you can also download it and save the logs to computer, and it'll download it to your PlatformIO. You can see everything right here. It's all the logs, information from all the readings is taken. It also gives you the option to clear the logs. That way you could do like a new research. Field clear, it's just gonna keep building up. And then go through, look at all the timestamps and determine which project was when. So you usually want to clear the logs first, then have it running, then download it. Then next, the Bluetooth for the pressure sensor. It's the same concept as the web server, allows you to clear the logs and type logs in the terminal up here, and print out the data that the sensor took. Wish there was a better program rather than this Bluetooth serial terminal, because it's kind of iffy. And this is another program that is for Android users. You can do it from your phone, and this is what it looks like right here. Same thing to other type logs, send the logs, and you could do clear. So it just says clear logs. And this is the app that you can download on your phone. I did it on Quan's phone and it worked.
Yeah, I think, isn't that the same app?
It's a different app.
Completely different app. I thought it was just
you can't get it on a computer.
I thought it was just like a mobile version of the same app.
No. And over here is after you save your data from here, you could transfer to computer. But I like the web server better. Then you got Cad Model, which is my way of showing where the pressure sensor would be integrated onto my classmate's Niskin Bottle. Over here, this is pending design, and right here, that's the pin for the weight at the solenoid. That's where the pressure sensor is gonna go. And if I'm not mistaken, there'll be holes drilled on the side. That way the water can go in there, get accurate readings. That's the threaded side going up. And this is the port where it will go in. It's like 3 different ports. That's the way. It's the solenoid area. Inclusion. And the key learning outcomes were better understanding of programming using Arduino, C++, and the different functions, ability to acquire and apply new knowledge as needed, ability to use technique, skills, tools necessary for science and engineering practice, ability to design and conduct experiments, as well as analyzing data, experience and independent learning. For the future, it would be nice to actually mount the sensor onto the Niskin Bottle, and also clean up the Bluetooth web server a little bit more for like better data, structured data results, and a lot more cleaner, prettier, and testing in the tank with the sensor on, make sure everything communicating properly. And also it'd be cool to add another sensor onto the Niskin Bottle, like a conductivity sensor to measure salinity, or like a dissolved oxygen sensor. Any questions? Was I supposed to put my fact sheet on here?
Not necessarily, no.
I just put one on there.
Yeah.
Looks like a good spot to put it.
Anybody have a question? For Stephen?
So how do you access where your data is stored?
How do what?
How do you access your data?
Like from the web server, you just go to your Wi-Fi in the corner, connect to the ESP Wi-Fi, and you just go to that link that I put on there, and it'll just show up like there's, that's the website. It just says it up there. We can't see the corner. Like that's just the what you see on the website. That's it. All the rest is blank. You just click download logs, and everything comes up to about here.
So this is not really an internet link, right? It's just a local connection between your computer and the ESP.
Like a wireless connection.
Right.
Right.
That's not going to, that's probably the IP address of the ESP, the 190, blah, blah, blah.
Like to the computer, like to the ESP Wi-Fi. Because if I'm not connected to the ESP Wi-Fi, I can't access.
No, you connected to the ESP Wi-Fi, but it's just a peer-to-peer connection between your computer and the ESP. That's not going out into the internet and back to your ESP. I think. But I'm not sure.
It's not like the ESP is connected to the internet and then you're connected to the internet. It's ESP and you connected together. But it's both are over Wi-Fi.
I mean, like when I connect to the ESP, I'll have internet.
On your computer.
Like,
Or what do you mean?
Yeah,
If
because
you connect to the ESP, you don't have internet.
no. It's like it says that connected to this right here.
Exactly, because you're connecting directly to the ESP. You're disconnecting yourself from the internet.
Yeah.
You're talking directly to the ESP.
No.
And then you can do whatever you do over Bluetooth, you can do over the Wi-Fi connection as well, right? At least in principle.
With Bluetooth.
But right now you use Bluetooth to set the temperature at a pressure threshold, right?
Yeah,
Do you use Bluetooth to set your pressure threshold or no? How do you set your pressure threshold?
No, I haven't gotten that far yet.
Because you don't
Like
need
where I
those,
can
you
type.
write
No,
it in your code, you hard code it into your.
not my code.
Huh? No, if you set the pressure threshold, you hard code it into your code on the USB, right? You write it in PlatformIO and then you upload it to you. Not like Andrew who can change his time by Bluetooth.
Mm-hmm.
But going forward, you can decide whether you want to do just Bluetooth or just Wi-Fi. You don't need both connections to your ESP.
I'd rather use the well, the thing with the Bluetooth would be nice to, because you could, well, what would be nice is you could set, say from the Bluetooth, like a pressure threshold, send it to ESP, and
But you
for
can do
like
the same
data.
with Wi-Fi. You can also hook up by Wi-Fi and tell him the pressure threshold. You don't need to do Bluetooth.
Yeah, you could do it, bro. You could set it with Bluetooth and retrieve it with Wi-Fi. The best thing for retrieval would definitely be Wi-Fi because
I like the way they.
the download's quicker
Yeah.
probably on Bluetooth.
Well, I
there's no
mean,
point
using
in
Bluetooth.
one way sending and the other way retrieving.
Very
If
true.
you want to stay.
It's very true.
One method.
How much
Like
data
sometimes.
you're collecting?
Huh?
How much data you're collecting? Bluetooth would be.
Well, I mean,
Bluetooth is plenty fast.
you think it'd be,
If I have too much data on the Bluetooth, like if I type logs, it won't show the logs. I would have to like clear first, then do logs, because it'd be like too much on the Bluetooth. While the Wi-Fi, you can see.
Well, it depends on how you program it. I mean, you can stream data over Bluetooth as well. But right now, your program right now records the pressure sensor, the pressure readings for a long time, right, and writes it into some kind of a file.
No,
So as your power goes down, it records the pressure, and then you could retrieve.
like it would just read, as it goes down. Once it reaches that target pressure,
Andrew,
it would,
for my order, I need the pressure sensor.
What about it?
you need a pressure sensor?
Yeah.
Okay. Got it. Oh, it's a whole other.
No, what I'm saying, of course, it triggers the release of your weight at a certain threshold, but also it records the pressure and the temperature as it goes down, right?
mm-hmm.
And puts it into storage. At the end, you can then read it out. And
That way you can just see, the change as it goes down.
Anybody else? Any questions? If not, then thank you. Very good. Good talk.